Hello, wonderful people of the internet. Welcome back to another episode of Simuleo. So today, let me go to clear the chat really quick. Today, we are going to be finishing up, maybe not finishing up, but working on some more animations for the Barnsley Fern video and chapter coming up. Hopefully, I'll start working on them tomorrow. I think if I really just try super hard, I can. If we get all the animations done today, we can actually get all of the the chapter and everything written tomorrow, and I think we could do it. We're going to have to spend a lot of time. We're going to have to spend a lot of time on one particular animation. So I'm not entirely sure how to make that animation, but we'll work on it. Currently working on my audition for a major character in the planned RP and the RP server I joined. Cool. Yeah, I hope that goes well. Okay, so let's go ahead and talk about the number of things that I want to do today. So first thing I'm going to do is I'm going to talk about what... we don't have to introduce what we're going to do because... right now, I'm pretty sure everyone who's watching has probably watched last stream. Otherwise, they wouldn't be here right now. Or are vaguely familiar with what we're up to. So I think we can just go ahead and go from there. Standards are high and my standards are higher. Well, good. I guess I'm happy to hear that. So let me go ahead and show a visualization that we made yesterday. CD projects, Simuleo's Fractal. Let's here. And let me just run MPV. I don't remember what I called it. Barnsley, low quality random? Maybe? No, that's not right. Yeah, that's not right at all. What did I call it? lstar.mp4. Barnsley Twiddle 1. MPV, Barnsley Twiddle 1. Okay, good. So here's a visualization we made yesterday. Bitrate is probably really bad right now, and that's what I want to fix first. So let's move this over here to the corner, and we'll talk about what's happening with that visualization in the corner. 1 second, move this down here. Over here. Okay, so essentially what this visualization in the corner is doing, I forgot to loop it. Loop 0. Okay, so essentially what this visual is showing is the Barnsley Fern as we modify one particular function, right? So the Barnsley Fern is composed of 4 different functions, and as we modify a single parameter, i.e. the x scaling in this function, we see that the tree gets larger and smaller, essentially, is what we see. Now, the other thing that you see is that it's kind of like just really a bunch of random noise. And the reason for that is that we're regenerating the Barnsley Fern at every iteration, which I think is what we have to do. But there is something that we could do that would maybe solve the kind of weird statickiness of this visualization, and that is if we use the same random seed for each generation of the Barnsley Fern. So if we reinitialize the seed every time we regenerate the Barnsley Fern. So that's what I'm going to do first, just regenerate or use the same seed over and over again. I don't really know how to do that in C++, so I'm going to have to try. So CD projects, Simuleo's Fractal, and same thing over here, CD project, Simuleo's Fractal. And yeah, I guess we're just gonna see how this goes. Okay, so VI Barnsley, actually, you know what? I'm gonna open up check.cpp. Okay, and I'm just gonna try something really quick. So int main, I think include random. I think I need to do that. Here, there, go there. I just explained what the animation is. Sorry, I can explain it again. But here we have the Barnsley Fern. It's made of 4 functions. We're modifying the x scaling of one of the functions, and that's creating... basically, the fern is going to be changing with in space. So you can see that it's kind of scaling in x. And if we modify the different functions, we get different visualizations. So this is one of... let's see, 4 times 6, so one of 24 different animations that we made yesterday. And again, we're just kind of cleaning it up today. So the first thing I want to do is just std cout rand, because I'm checking how random numbers work. So over here I'm running g++, check.cpp. Okay, that didn't work. That demonstrates really well how each leaf is a smaller version of the fern itself. Right, so we want to do this with all of the functions and all of the little things that we can modify. So we'll get there in just a second. But again, we just want to make it so our bitrate doesn't tank when we do this. So I think I forgot that. there. Try that again. I probably just forgot C++. vi Barnsley .cpp. Include IO stream, right? I just completely forgot C++. Check.cpp, include IO stream. Okay, try that. G++ ./a.out. Out. Okay, so now what I want to do is I want to like create a random seed and stuff like that. So let's go here to random seeds, C++, and see what we got. srand. This is like not the website I want. srand there is probably what I want. Okay, so we want first number, printf srand. Okay, so I want to do the following. srand 1 cout and yank to yank, and I want to make sure this is the same number. That's all I want to see. G++. I forgot a semicolon there and there. Try it again. G++ ./a.out. Yes, it's the same number. Perfect. That's what I wanted to see. Okay, so now what we want to do is quit over here via barnsley.c++. Go down here, and what I'm going to do, we have the Barnsley twiddle function. Let me just mess around with that really quick. So we're going to do Barnsley twiddle in there, and then we're going to run cam world. I guess 10,000 is still fine. And then we want, let's just do 1, 0. So we're going to regenerate the animation that we see up there in the corner. Okay, so the next thing I want to do is basically make it so, yeah, basically redo, wait, where's Barnsley twiddle? 1 second, there. We are there. So what I want to do is I want to make it so here, the rand in there is going to be reinitialized with every step. So let me think about this really quick. Wait a minute, I have 2 I loops. Am I just dumb? 4 int I here, and then I have another int I in there. So that's okay. Let's fix that. So I want to change the inner loop in here to be j, rj. 1 second. Is there any time that I actually use I in here? I don't. Down here. The ball color. Change that. Change that. That. And I think that's what I want. I don't see any other usage of I. So we should be good to go from there. Yeah, I think that's right. Okay, and then up here, before we do any of this, I'm just going to do srand 1337. Doesn't really matter as long as we're using the same seed every step. So now we're going to run G++. Oh, sorry, it's the wrong G++. History grep. 1 second, G++. And then I want to run 390. Okay, and then this should be correct. Yep, so /Barnsley. And we're going to give that guy just a second to run, and then hopefully this will be a cool looking animation. My first step was to do a detailed character study of the person I'm auditioning for and how they act in canon. My second step, which I'm currently executing, is to think about that character constantly, letting my mind wander around it as I do other tasks, writing and observations as I have them. I'm shower thinking myself. Yeah, that's kind of how you have to write some of these characters sometimes. Well, I mean, everyone has different ways of creating characters, right? So, yeah, it kind of just depends on how you want to do it. How are you doing this? So there's a live streaming software called OBS, Open Broadcaster Software, and I have that on my desktop, and that allows me to stream to Twitch. And that is currently how I'm doing this, I think. What question? What is this? Sorry. Make the animation. I'm making the animation with a library called GathVL. It's, you can just Google it 1 second. Here, GathVL. It's a C++ library that here, I can give you a link to it. Over here, algorithm, github.com. And then 1 second, let's go to, I think I can just do GathVL. Yeah, there it is. No, that's the wrong fork. I want to go to this fork. Okay, so I'm using this library right here. And then essentially what we're doing is we're taking the Barnsley Fern. It's composed of 4 functions, and we're modifying one of the elements of one of the functions, the X scaling on that function, to basically change how the tree looks as you go further and further on. I should be regenerating that visual right now. It's taking a little bit longer than I remember it taking. I think maybe that's because I'm using a few too many points. So, which browser are you using? I'm currently using the Qt browser, Qute. Qute browser. So it's not a dummy question. Anytime people ask about desktop things, I mean, it happens. People definitely have questions about like the setup and stuff like that. If you have specific, like if you want to like use the setup, it's actually available on Discord right now. You can just go to Discord. It should be in the general chat, and there should be like, it should be pinned or something there. So it can be done with any other library, right? Like STL. Yeah, it can be done with any other library if you want, as long as you can do an iterative function system or chaos game with it. You need a bot for that kind of thing, browser or FAQ. Yeah, so I do have an FAQ. It's just no one has ever asked about the browser before. I think that's because I used to just use Firefox, and I only really recently started using Qt browser full time. It used to not do very, very well on Twitch, which is why I didn't use it. And I used to use LuaKit and stuff like that instead, but I recently switched to Qt browser because I don't know, I prefer it. It's quite nice. Okay, so it looks like it's done. So let's do mpv temp video.mp4. I forgot that it had a white background, and also just realized, okay, well, good to know. I just did 2 visualizations in one, but it worked how I wanted it to work. Perfect. Okay, so let's modify it so it doesn't have a white background anymore. Also, I'm not entirely sure why the color there was so weird. Like, I was expecting it to be more green. So let's redo this visual. I now understand why it took so long, because I was doing 2 visuals in one. Comment that out. And now let's run G++, but I'm going to change the background color again to be black. Here. The default color is black, so run it one more time. And then /Barnsley, and this should take way, 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 way less time. Probably half as much time. I'll try that. Do you have this algorithm on GitHub? I have the algorithm on GitHub. I do not, on the algorithm archive, right? Here. This particular one, so here's iterative function systems, chaos games, and all that kind of stuff. I'm writing the Barnsley Fern chapter tomorrow, but this kind of gives you an idea of how it works and all that kind of stuff, and you get an implementation of iterative function systems in a number of different languages. So we have Julia, Python, C++, Coconut, C, all that in here. So that's chaos game, and if you go all the way down to the bottom, you can see the full implementation of all the different languages here for just a chaos game. The Barnsley Fern basically switches out the Sierpinski triangle functions with an additional Barnsley Fern function, which you can find on Wikipedia. But if you can understand one, you can understand the other. It's kind of a similar process. So, but we're actually going to be writing a Barnsley Fern chapter tomorrow once we get all the visuals and everything done. So, okay, let's try running this one more time. MPV video. Okay, so, okay. It's not as green as I was anticipating it being, so we need to figure out why it's not green anymore. But this is actually the visual that I was looking to do. And let me try to explain to you what the difference is between this visual and the other visual that we had. So watching this visual, let me just, you'll note that, okay, look at this visual, okay, watch the stream, look at my face while looking at that visual. Now, look at this visual, and look at my face while this visual is going on. And I think you'll clearly see the difference. The main thing is that basically every frame of this video is a new generation of the Barnsley Fern, right? You have to regenerate all 10,000 points at every frame. Totally fine. PJ Brazil, thank you so much for following, which is great, but that means every individual frame has a new distribution of points. So going frame by frame, you completely change the Fern, right? And so what I just did is I made it so the random, basically by going frame by frame here, you don't change that distribution. The distribution stays the same. And I did this by basically forcing the random seed to be the same between all the different steps. And so, yeah, it still blows up and does this weird thing, but it looks better because you don't have the weird, like, I don't know, Fern pattern at every step. So we can just focus on the movement. We don't have to focus on like the random bubbles and everything. Okay, so now let me see why that wasn't particularly green. So here I'm going to just play that one on loop. So it's up in the, well, let's move temp video.mp4 to Barnsley twiddle2.mp4. And I'm just going to play that really quick. So that'll be up in the corner as we fix it. So this will be in the corner up here as we mess around a little bit. Perfect. Okay, so the question is, why is it not green? It's a fern, should be green. Looks amazing. Yeah, I'm glad you think so. Okay, so I don't exactly know why it's not green. So let's try to figure that out. Okay, so in the Barnsley twiddle function, twiddle, I modify the color of each individual point according to a function that is going to be, the ball color is going to go from 1 minus double of n minus j, okay? So that means it starts at 1 and it starts at 0. No, wait, I need to think about this. 1 minus, 1 minus double of n minus j. So the idea is that as j increases, red, green, the green value should also, is that increase or decrease? I need to think about this really quick. It's 1 minus 1 minus double of n. So it's 1 minus 1, which gives you 0. And then as j increases, as j increases, it gets more and more green. Totally fine. Okay. Then the next color is the blue color, and it says j minus double of j over n. Let me put some parentheses around this. I don't exactly think that's working the way we want it to work. Okay, so what this will do is it says j. No, that doesn't work at all. What's going on there? As j gets closer to. What is going on? Wait, it should be that it gets less blue, so it should be going down to 0. So at j equals 0, we should have 1. Red, green, blue. So for blue, it should start at 1 and then go to 0, and green should start at 0 and go to 1. So does green start at 0? It's 1 minus double of n minus j over n. So if j is 0, then it's 1 minus 1, which is 0. Perfect. So this one is just j minus double of j. That doesn't make any sense. That's just always going to be 0. Okay. So I think I see what's happening there. So we want to make sure that this goes to green. How did I do this before? Are you a graphics programmer? No. I'm not a graphics programmer. I got my PhD at the Okinawa Institute of Science and Technology. I mean, it says Unapologetic research stream because we're literally doing we're studying chaos games right now. In particular, the Barnsley Fern and stuff like that. I think it's one of the eyes you replaced with line. Yeah, I realized I did that. I just need to figure out which one. So let me just go down to the next ball color and let's just go there because I know the other ball colors were right. So it's 1 minus double of I over n. I see. So here it should be 1 minus double of I over, double of j over n. Is that correct? So as j increases, yes, that is correct. Write this, go over here, run the last g++. Perfect. Run /Barnsley. And actually what I'm going to do is I'm going to run a higher resolution version of this image. So I'm going to increase the number of points by that. Deleted. Yeah, so I didn't need the parentheses anymore. G++ /Barnsley. And this should do it. So we should see a relatively green fern with some blue background. Give it a second to run. I'm increasing the number of points by 10. So I'm assuming it's going to take, I don't know, like maybe a minute or two to generate. Thanks, by the way, Gibbous, for the call there. Okay. But once this is done, we should be able to make relatively good, high-quality visuals for this particular visualization that we're looking for. Then, after that, we can move on to the next visual, which will be basically taking each individual function and modifying it. How do I put this? So the Barnsley Fern, again, is composed of 4 functions, all of which are like affine transforms. They all move a distribution of points to another location. So what I want to do, what I have already, is a distribution of points generated by just some random number. And then I have all of this random distribution moving according to these transforms. But what I want to do is create the Barnsley Fern itself, and then have the Barnsley Fern be modified by each transform. I'll explain it a bit better in just a second. Let me wait for this to be generated. And also, while we're doing this, let me go up to this function that we have for the Barnsley Fern and go from there. Do we need an external library for rendering to an MP4 file? You should just be able to run the Gath. Right. So you should need the GathVL library, which will be. I sent you the link earlier. I think I sent you the link. Yeah. So if you just run make lib on the GathVL directory, you'll get the library that is GathVL, and then you can load that in using the compilation instructions up here, G++, this guy. Yeah, that should work. Okay. And it's available on my Simuleos GitHub as well if you want to go there. Okay. I'm going to do it with OpenGL. Then I don't know how to do it with OpenGL. Sorry about that. I mean, so with OpenGL, like, the problem is you probably have to think about shader logic with that. And though it's totally possible to do an iterated function system with shaders, like no doubt it's definitely possible. I haven't done it yet, and I don't remember the hard part there. The problem is shaders, like iterated function systems are inherently iterated, right? Which means they don't do very well with shader logic. So you have to like think about how you're going to do it, and it could get a little bit complicated. I don't know. It's probably fine, but to do it efficiently is probably a bit slow. Or like you probably have to think about it in a bit more detail. Okay. Let's go to Twiddle. Here. Okay, so that's done. Let's take a look at MPV. Temp video.mp4. Yeah, that's what I wanted to see. It's still really messy, but it's not as messy as the last one. Yeah, that's quite nice. Okay, so I'm going to move that over, and we're going to have that playing in the upper corner while we work on the next visualization. So let's go ahead and move that. MPV. Yeah, again, it is still very messy. My bitrate is still probably going down, but it's not going nearly as down as it was before. Cool. Okay, so we can do that with all the animations in just a bit. So what I want to do next is, I want to take a look at this guy really quick. So this is implementation of the Barnsley Fern. In here we have this. Yeah, okay. Okay, I see what we have to do. Okay, so let's talk about what we're going to do next. I'm going to play a few videos. So ls*.mp4. Okay, mpv barnsley 0.mp4. Okay, so 1 second. Your bitrate takes a hit whenever the Fern turns into a cloud. Yeah, I figured it would. I mean, clearly that's like a lot of points going all over the place. It's the same problem with like with confetti or whatever, but it's going to be way better than like it will be better than it was before. Like before, like every single one of those confetti images was completely different than the previous confetti images. At least now, like each individual bit is like related to the one before it somehow. So like you can kind of sort of see where it's coming from. It's still really bad though. Like I know that the bitrate's not going to work very well. Okay, so the next visual that I want to do, we have these 4 different transformations for the Barnsley Fern. One transformation takes a distribution in points and turns it into the stem of the fern. Oops, sorry about that. I hit the microphone. The other another transformation will take the distribution of points. 1 second. Okay. The next visualization will take the distribution of points, and it will kind of move it up a bit and to the right. So that's all it did. So it just moved it up and a little bit like this. The next visualization, the next one, will create essentially the left-hand leaves here. So here it kind of like, that's a stem operation, sorry. The next one will create the left leaves. So see how it kind of rotates and moves over this way. So that'll create a left leaf. And the other one kind of creates a right leaf over here. So this one will flip it over and create the leaf over there. So we have these 4 visualizations, and I can tell you what these are doing, but I think it makes more sense if instead of starting with a random distribution of points, we start with a, 1 second, an actual Barnsley Fern that we're reading in. So I'm gonna do that, and we're gonna see how it goes. Okay, so let's see, what was that? That's apply affine, apply Barnsley. Yeah, individual ID. So what do we have? The individual, I think I just called it Barnsley Transform. So let's go to the Barnsley Transform function. Yep, here we are. And I think I'm just going to kind of copy this and work off of it. So let me see how this is currently working. So right now we create a vector of points. Yeah, so we create a vector of points, which is of size n. Yep, and it's just a set of balls. Yep. Yeah, so all I want to do now is make it so the Barnsley transform, I guess we'll call it the Barnsley Fern transform. It's a bad naming convention. What I should do is probably change this function, Barnsley transform. Yeah, okay, because I do want the random distribution of points so that I can, like, yeah, because I want that visual as well. So I want more, like, I want multiple visuals, right? So I want to keep that other visual as well. So I want a separate function for this. I just realized, Gibbous, okay, you might have been telling me that, like, every time this visual in the corner goes all weird, like, my bitrate goes bad as well. Let me check that on Twitch really quick. Oh, it does actually. I think, wait. Let me watch that again. So I guess I'm going to be waving over here, and I just want to check. I see. I misunderstood. I'm going to check the bitrate really quick. Okay, so now I'm going to go over here, and yeah, that's what I expected. Okay, yep. So let's do another visual then. That's not that one, because that one goes kind of crazy. So let me just generate another one that isn't as bad. We generated them all yesterday. Let's think about one that actually looks good. We can change the Y scaling, X scaling, X movement, X shear. What happens if we change the X shear? Okay, let me do G++. That's /Barnsley, and let's let this one run. And in the meantime, I'm just going to have mpv barnsley.mp4 playing in the upper corner. Yeah, I mean, this is what I get for, like, streaming at a bitrate of 2500. I should be streaming at a higher bitrate, but I forgot to loop it. But the thing is, I never know if I'm gonna have quality options before stream starts, and so, like, streaming at 2500 means that most people can watch the stream no matter what I'm running at. So I always stream at kind of a lower bit rate, but it does mean that, yeah, of course, like, some things like this will end up looking bad. Like, if I ever play video games or something like that on stream, like, they all just look bad because I don't have a high enough bit rate for that. But I think today I do have quality options, so if I could just, if I wanted to, I could increase the bit rate today. That's what I'm saying. Context. I don't know what I said that was out of context, so I don't know what the context command is supposed to do. My guess is that you're asking me what we're doing today. And essentially, if you see this Fern in the upper left-hand corner, we are doing what we can to, like, basically explain how we generate that Fern. So this Fern is basically generated from 4 different functions. One creates the stem, another creates successively smaller kind of leaflets as you go up, another one creates leaves to the left, another creates leaves to the right, essentially. And so what we're doing is we're kind of modifying these functions to show exactly that. And so we're creating different versions of this Barnsley Fern by modifying different, factors here and there and doing that kind of stuff. Hey, Alexor, how are you? I'm so sorry. I've been, like, I really have been trying to stream, like, more regularly recently, but, like, I can't, like, every single time I try, there's something that comes up where it's like, well, I can't stream today because, I don't know, a realtor is coming by right in the middle of when I actually had time to stream, or, can't stream today because, I don't know, my roommate has someone coming over or something. It's just been, like, constantly something has been in my way, impeding me from actually, like, doing stream, or, like, throughout this week, like, every single morning I've had to, like, go to Boston for some reason, and it's just been, I don't know, it's just been really busy, and I haven't really had time to do what I want to do. Okay, so that's not what I meant to do. mpv temp video.mp4. Okay, well that's another transform. That one is not. I mean, it's fine. I guess. Um, 1 second. Let's see if we can make a better one. So I am going to, I'm still going to move that over a bit. Let's see. Move temp video.mp4 to Barnsley twiddle. I'm going to call it 3.mp4. And let's just check another one. So the next one's going to be a linear shift along X, which we don't necessarily want, but I think we could try scaling along Y and see what happens. Yeah, so that's going to be 1, 2, 3. I maybe we want to scale. Oh, just why do I suck so much? There we go. Right, this. Go over here. I'm going to try that really quick. We're just going to make a few of these, and then we're going to move on to the next visual after that. And then hopefully I can just start working on the algorithm archive article once this is done. Just kind of putting everything into place and trying to figure out how we're going to write it and what makes the most sense. So that's my hope, is that we get into that today. I actually was finally able to find statistics for the algorithm archive today for the first time in a very long time. Because essentially Google Analytics just wasn't working with HonKit for some reason. I don't exactly know why. It just wasn't. And so when I was trying to find analytics, I couldn't. So I'm happy to say that actually the algorithm archive gets about as many views as I get on YouTube. Obviously it's not as monetized, or it's not monetized as well, so I get more like money off of YouTube. But I'm happy to say that the algorithm archive does get, relatively high viewership. Not super high, but, on the order of, 30,000 to 40,000 views a month, which is good. Depending on the month, sometimes it's lower, sometimes it's higher. And that's pretty good. I'm pretty happy with that. So, if I just put more content out there and there's more available on it, I do feel like, more people would be, not only willing to use it, but also like willing to support it and stuff like that. So I'm actually like really motivated by that fact. And, I'm really hoping to, just make much better content for it than I was before. Because I've mentioned this before, but like I'm not much of a video content creator. I kind of make videos because I feel like I have to. But the algorithm archive articles I always make because I want to. And I don't know, if I could just like spend all my time just writing the algorithm archive, I definitely would. Like that's like a no-brainer, doing the algorithm archive and also doing relevant research as well. So I think in some sense, like the Twitch stream would always have to be there. So I don't know. I don't exactly know how to balance everything. But anyway, that's just kind of stuff that's been running through my mind recently. I'm still waiting on this to render, so let's give it just another second to see what it looks like when it's done. Again, this should be a scaling along Y. So what we should see here is like kind of, we should see we should see the fern growing up and then growing back down, I think is what we should see with this one. It's still rendering, so, yeah. Hey, C252, how are you? I think it's been a long time since I saw you on stream. How have you been? I see you highlighted your message, even though I don't see it on stream. I do see it over here on my side stream. Yeah, we're just messing around with the Barnsley Fern, making some visuals and stuff like that. We're going to move on to the next visual in just a bit. Just wanted to make one more. Okay, let's see what this looks like. MPV temp video.mp4. It always looks weird. Is this a... No, this was a shear along Y, not a scale along Y. Maybe I'll have that one playing the upper corner. I might do a scale along Y as well. Okay, I'm going to make one more, which is a scale along Y. So let's go ahead and move this over to Twiddle 4. And now we're just going to do one more, which is a scale along Y. And that'll be it for these visuals, and we'll move on to the next one. G++, /Barnsley. Move over here, Control C. And I'm going to modify this to Barnsley 4. Barnsley Twiddle 4. 4.mp4. Okay, so we'll have that playing in the corner. It won't like ruin my bitrate like the other one was. So that's one advantage to this visual. Pretty good. I haven't had too much time for streams during the school year. That's totally fair. I haven't had too much time for streams like during the school year either. CTV2, thank you so much for the 19-month subscription. Let me go ahead and put 19 Stimulus cows in the chat. That was, I promise that was all English. It was just all really like very, I don't know what happened there. But thank you so much for the subscription. Really appreciate it too. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There you go. That should be 19. 3 by 1, 2, 3, 4, 5, 6. Yeah, that's 19. Okay. MPV temp video.mp4. Okay, that's going to ruin my bitrate. Yep, that's just... Does it even come back? Or is it just gone? It seems to just be gone. I don't exactly know what happened with that one. So it scaled all the way up. Why did that one break? Wait a minute. What's going on with that visual? They're all gone now. And the reason they're all gone is because we're going to have to fix that, aren't we? Okay, let me think about this. As we're scaling up in Y, I actually don't understand what's happening. So let's just take a look at the Affine Transform, apply Affine. We're looking at this guy. So, and we're modifying this 0.85 times point.y. Oh, let's apply Barnsley. Let's go down to the Affine. So we were modifying 1, 2, 3, 4? Or were we modifying 5? What were we modifying? We were modifying 4. So Affine, we were modifying 4, which is 0, 1, 2, 3, 4. This is 0.085. And we were bringing it, so we were going all the way up to 1.3 something. Right, so we're adding 0.5, and then we're subtracting 0.5, and then we're going back to 0.85. Why would that break? I think it breaks when it goes over 1. And I'm not exactly sure why. Yeah, I'm not sure why exactly at all. Let me think. I mean, there'd have to be like some values that are just nans for some reason. Let's just regenerate that really quick, and let's just see what happens with all the points. So I'm just going to output the point locations really quick. So let's go up to 1 twiddle, and let's try to fix that visual. So in here we have apply affine, we have the vector location. So what I want to do here is after the vector location is created, I'm just going to do std cout pt.x new tab pt.y, new tab location .x new tab, move this down to the next line, location.y, and then new line. Okay, over here we're going to run g++, and then /Barnsley, and let's just see what happens. Oh, that's a lot of... Right. Yeah, okay. Yeah, I forgot that we have... we have a lot of points that we're generating, right? So, should we just let it go and just wait until we get like a random number that is just like a nan? Or should I cancel it because I know the output... Yeah, I don't know what to do in this case. How many points are we generating? We are generating like 10,000 points? Way too many points. Yeah, okay, let me just go ahead and cancel this then. How do I actually want to do this then? So every time we generate a new point, we are... Well, okay, every time it pauses, we know we're moving on to the next frame. So maybe let's just, there's only a maximum of 600 frames, and it's taking 2 seconds per frame. So it'll be fine. It'll just take 1,200 seconds. But eventually it'll hit a nan, and we can figure out what's going on when it hits the nan. Maybe. Let me... I just... Now I feel like there's a sunken cost fallacy. Like, I know I should cancel it. Like, I know I should cancel it, but I'm not... Maybe I'll just let it go for a second. Yeah, maybe I'll just keep letting it go. If you guys have any questions, comments, concerns, ideas, anything like that, feel free to let me know. Totally address it as soon as I see it in chat. Otherwise, Yeah, we're just going to keep... Aha! Wait. The point locations are going super high now. Yeah, they're going super high now. They're at like... Yeah, okay, I see what's happening. No, they're super low? I can't tell. Yeah, so here's our nans. Perfect. So we're getting nans. I just don't know how or why. So I guess what I want to do is Control C in here. What do I want to do? I guess we can tell at what frame it blows up, right? And then we can see if we can see what the value is at that point. Yeah, we can see what the value is at that point. So we'll look at twiddle val. So what we want to do is output. Yeah. So what I'm going to do is output the following. I'm going to do std cout I, and then we want to do new tab and fx set, which is our function set of function number, and then the affine number, and then new line. Okay, I'm gonna go down here and remove these std couts because they're completely useless now. And we're gonna do g++ and /Barnsley, and hopefully, yeah. So it's just outputting stuff. Yeah. So as we can see, it is slowly increasing. We have 600 of these to do, so I think I'm just gonna let it go. Again, guys, feel free to say whatever you want. So we're about 1/10 of the way in. And as you can see, it's a lot faster. I think this is because there are fewer points on screen. And then at some point, I think, yeah, there, 1.3, I think is when we get everything to be just completely nan. Why would that be the case? Yeah, so everything's nan at like frame 130 or something like that. I'll check to make sure, but I think that's what we're looking at here. Okay, so let's do MPV. Temp video.mp4. So 130 is going to be frame 90 or something. Darkstone Digital, hey, thank you so much for the raid. Really appreciate it. I'll talk about what we're doing in just a second. If you, also for the record, my bitrate's going to go really bad in just a second. I'm so sorry about that. But yeah, feel free to talk about your stream, how your stream went, and then I'll introduce what we're doing over here in just a second. So we said it was going to break at frame 130, which is going to be, what is that, 2 seconds in? It's going to be 1 second, 2 point, wait, where's the time? 8, 7, yeah, it's something in here. And that's exactly when it breaks. Yeah, perfect. Yeah, something like this. Okay, well, anyway, neat, went well, just modeling stuff. This is kind of cool though, this fractal stuff. Yeah, so we are doing kind of a number of different things. So right now what we're doing is looking at a particular iterated function system known as the Barnsley Fern. If you're interested in how iterated function systems work, feel free to go to my chapter already on the algorithm archive for this. Again, you can change like all the languages and stuff if you want to the languages that we have available. And it also gives you a description of like exactly how the iterated function system works and all that kind of stuff. It's a bit long, but the code's all there and everything. Essentially, the same code that can be used to generate the Sierpinski triangle, as shown kind of here, can also be used to generate these Barnsley Fern functions. The Barnsley Fern is just another set of functions to do that. So what we're doing is we're kind of modifying the Barnsley Fern functions, trying to get good visuals to explain how exactly the set of functions that creates the fractal actually creates the fractal. So that's what we're working on right now. Again, this is all related to a bunch of different projects. For example, the algorithm archive, and of course on YouTube as well. So it's all kind of connected to this type of stuff. It's a channel and kind of book on algorithms and stuff like that. The idea is, we're trying to collect as many algorithms as we can in as many languages as possible. So like here's Monte Carlo, and you can just kind of switch between any of the languages that we have for that. And this is kind of the resource that we're working on right now. More water. Wait, did Botuleo's change? Oh, I see. No, I don't have it today, command updated. I'm sorry about that. Lazy, thank you so much for following. Really appreciate it. Eventually, we're going to be looking more into details of like how to create these iterated function systems, how to basically turn any image into an iterated function system so that we can compress it. This is known as fractal compression. We're slowly getting ourselves there, but right now we're just taking a step back, looking at simple fractals, like for example, the Barnsley Fern, and going from there. However, right now in one of our visuals, it's breaking, and I don't exactly know why it's breaking. So the visual that we're looking at right now is a modification of the Barnsley Fern, one function in the Barnsley Fern, to make it, I think this one, scale along y. And when we do it, we see the following thing. We see this weird, so it's obviously scaling along y, but then it just kind of breaks. And it's not clear why it breaks. So what it should do is it should scale up, and then it should scale back down. But we're not seeing the scaling back down. It just kind of breaks, and we get a bunch of nans. And I'm not exactly sure how we get the nans, because so far as I'm aware, we don't have any divisions here. So we're not dividing by 0. We know that it basically becomes nans at like 130 when our, let's see, when our value for scaling along y becomes like, let's see, what do we have here? Like 1.28 or 1.3 or something like that. So again, I'm not exactly seeing how or why this breaks at that stage. So we're trying to figure out why it breaks, and then we're going to move on to the next visual after that is done. I'm hoping to get both visuals done before I end stream today. And then tomorrow we're going to kind of like finish the visuals, finish up the chapter on the algorithm archive, and then hopefully on Sunday we can just make a quick video. I'm not very good at making quick videos. Videos always take me forever to make because I spend way too long editing. But I think I'm going to try like a new style that people probably won't even notice is different, but will like help me make the video way faster. So we're going to see how that happens or how that works. Okay, so why is this breaking? So our location then, so what's going on? Our point here is going to infinity at, our point location is going to infinity when that particular variable is set to 1.3. Now that doesn't make any sense, but that is exactly what's happening. So is this because we're sharing the same point and somehow there's like some sort of like, Okay, so we have basically some sort of double random value here. So where are these points? So the point is going to be apply affine to some point location function set here. And then we have the vector location. We're regenerating this point every time step, right? So we have 0. Yeah. Okay, so just for the record, for those who might not be following, the way this works is we take some point, and that point's going to start at vector 0, 0. Then the idea is every single step we choose a random function from 4, and one function will basically create the stem of the Barnsley Fern. Another one will create successive leaves as you go up and kind of to the right. Another one will create left leaves. Another one will create right leaves. So it's kind of a way in which we iterate through in a random way and like recreate our Barnsley Fern. It basically create a fern inside of ferns inside of ferns. So that's kind of how it works. So every time step, we're initializing our point to be at vector 0, 0. Then what we're doing is we're specifically choosing a random seed. I just chose seed 1337. And the idea is if we choose 1337 as our seed, then we're always going to be choosing the same function set. So we're always going to be choosing function 1, function 2, function 3. And this basically means that we don't get like some sort of like random noise gradient as we're going from like one to the other. So we're basically regenerating the fern at every time step, right? So what I'm going to try next is I'm actually going to try to lower the number of points here to be at 10,000 instead of what we had before. So now we're going to run G++. I'm going to run /Barnsley. And then we're just going to see if this one also breaks. Because it could be, basically we're taking the same point and we're applying this function 10,000 times, right? So there could be a situation where our point goes off the map and then somehow by multiplying, like, I'm not exactly sure. So I'm going to run mpv temp video.mp4. So this one goes up and then it goes back down. So that one works. I'm going to see if we can figure out at what point this breaks, because that one works just fine. So what I reckon, or what it seems to be, is that with every transformation, with every multiplication, there's a little bit of error that is accrued, and that error seems to just add up a lot. So let me multiply this by 5, And now we're going to do g++ dot / Barnsley, and we're going to see what happens here. Again, it's 600 frames, so this is kind of like I'm just watching this to see how long it takes. And so again, we should see it, kind of scale up and then scale back down. I'm afraid it's not going to scale back down. I don't think it's going to scale. I think this one's broken. This one's definitely broken. Okay, so this one won't scale back down. So if we're going to MPV temp video.mp4, yeah, so this one is just going to go up and then it stops. Yeah, it's broken at this point. I don't understand that. I don't understand it at all. So, I mean, again, this must mean that we're accruing a little bit of error at every time step. And somehow this is going to, somehow it's just going to infinity. Like, it's just getting really, really big. And I guess that would happen if okay, if we scale along y at 10, okay, so the top of this image is 10, right? So if we scale along y, we can make it up to 15. Okay, and okay, I see how this could happen. Okay, yep. I totally understand what's happening here. What is happening here is because y, the y scale factor is going from 0.85 to something above 1. We are no longer contractive, right? We're now expanding. And because we're expanding, there is a possibility if we choose that same function that is expanding more and more, we will eventually make it too big, right? Such that it's so big that we kind of create random numbers, and that's exactly what's happening here. So what I'm going to do next is I'm going to make sure that these are contractive. So the way I'm going to do that is by, how do I want to do that? Let's see, what is the best way to do it? I could just make it so, the most you can like the 0.85, the little twiddle factor here, can only go up to 1, maybe? Let's just see what that visual looks like. And so it kind of clips at 1, and then we go from there. So let's go, it is right here, and I'm just going to say if this guy is greater than 1, then we just set it equal to 1. And you guys are just going to have to deal with the fact that these are clipped a little bit. There. And then we're going to say this guy equals 1. Okay, let's write that, go over here, and now we're going to write one more time, g++. And this one I don't think will blow up. I'm dumb. If this is greater than 1, there we go, g++ dot / Barnsley, hey Trash Talk, how are you? Okay, so let's try that now. So there will be a little bit of time in this visual where it kind of scales up and then it stops for a bit, and then it will scale back down after that. So I want to see how long that pause is. Yeah. So I'm watching, and then it should start scaling back down soon, I think. 1 second. Yeah, there we go. So now it's scaling back down. All right, so we'll look at this visual in just a second. This should also keep the Fern from going too high off the map as well. So give me a second. It's 600 frames, so yeah, it's fine. Let me check over here. Okay. And then we'll think about what we actually want to do here. I think maybe what we want to do in the case where, I'm not really sure, but I think what we want to do in the case where like the Fern can't grow that big, which will be certain cases, like there are the scaling along X and the scaling along Y for a couple transforms just can't go above 1. So in these cases, maybe I'll like skip forward a few frames or something like that. So let's do MPV. So this one should work. It goes up and then it stops for a bit. kind of a long while, actually, and then it goes back down. Yeah, maybe what I should do is I should make it so we skip forward a few frames in this case, I think. Yeah, let's see, what do we have here? Like, okay, so if I is greater than that, yeah, okay, I'm literally just going to skip forward a few frames, and we're going to see if this works. So, how do we want to do this? So, in the cases where we're adding something here, so it can only work in this. Wait a minute, how's this going to work? So we have the twiddle value here. We know what we're adding in. Trying out web dev. Oh, I hope that goes well. Honestly, I'm always very scared of web dev. This is totally realistic simulation of a fern leaf under windy weather. Yes, it's 100% realistic. You will never find more realistic visualizations than what you find on this stream. I strive for some of the most beautiful graphics you've ever seen that are 100% in line with what you'll see in the world. Admittedly, it's a really dark night when I took this visual, but CSS is surprisingly hard. It's annoying, isn't it? But you get kind of used to it. Okay, so the twiddle val here, what I'm going to say is the following. While, how do I want to do this? Oh, I know what I want to do. While the twiddle value should be equal to 0. So while, So if I say while some value, so function set of fx num of a num plus twiddle val is greater than 1, we'll say greater than or equal to 1. Okay. Then what I'm going to do is yank, paste, I plus. So I'm literally just skipping, and we're gonna see what happens. The raindrops and reflections are stunning. Yeah, I mean, it took me a while to render this, but it is what it is. Bugina, thank you so much for following. Really appreciate it. Sorry, I'm not very good at name pronunciations. Okay. So what's the idea here? The idea is we're just going to keep modifying the twiddle value and keep increasing by 1. Yeah. Maybe this is what I want. Let's just write this and let's do g++./Barnsley. And I'm just watching this value. It should go up to 1. Oh. Right. That clearly didn't work. That's because it will always be greater than 1. Okay, so I want an and statement in here. And I is less than frame num over 4. Okay, g++ ./Barnsley. Hopefully this will work. Oh no, it didn't work. No, it totally did not work. Yep, no, that didn't work at all. We're just gonna have our fern grow up and then stay there for a while, and then okay, what I could do is I could modify the I could modify the twiddle value a little bit so that it doesn't grow as big. Yeah, so it doesn't grow as big, maybe? Yeah, maybe I do it that way instead. Yeah, that's actually probably a better way to do it. Okay. D. Okay, so in here, we have all these 0.5s for the twiddle values in here. So what I'm actually going to do is create a new value called double twiddle max is equal to 0.5, right? Hear me out. And then we're going to say if 1 minus absolute value of fx set of x number of a number, if 1 minus absolute value of fx set. Okay, what is this going to say? So if this is less than 0.5, okay, then we're going to set twiddle max is going to be equal to this guy. So what this will do in the case that we have already have some sort of scaling factor, what this will do, like for example 0.85, this will mean the most that we can scale up and the most that we can scale down is now going to be 1.5 or 0.15 in this case. Yes, I forgot a parentheses, but I think outside of that it should be fine. Yeah. Okay. So now down here, what we're going to do is we're going to modify all these 0.5s to be twiddle maxes. Twiddle max. 1 second. I need to think about this really quick. It's going to be 0.5, so it's going to be twiddle max minus... Yeah, we have to change all the 0.5s to twiddle maxes. So set number, and let's just do, let's see, it's from 83 to 90. I think... Wait a minute. Yeah, it's 85 to 90, so let's just do 85 to 90 S. And it's going to be 0.5. Maybe I should do it this way. To twiddle max, and then do CG. This is going to be 0.5 times frame number, so that's no. 0.5 times frame number, no. Yes. 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 Okay, so this should be right. So it should be twiddle... Oh no, I misspelled twiddle max on one of them. Okay, let's see what that does. So I'm going to run G++, should compile, /Barnsley, and this should just go up to 1, and then hopefully drop down to like 0.65 or 0.6 or something, and then go back up to 0.85. So it is going up to 1. It is going up to 1. Give me a second. It's stuck at 1. Dang it. Oh, is that because... Why is it stuck at 1? Why did it get stuck at 1? Okay, wait a minute. So the twiddle value here is going to be I times twiddle max over 0.25 times frame number. Okay, should be totally fine. The next one is going from, I think this should be twiddle max. Okay, try this again. Control C, G++, /Barnsley. I don't understand how that, maybe I just grabbed the wrong numbers when I was doing this a second ago. All right, try Barnsley again. Okay, we're watching. It should go up to 1, then it should drop back down to, like 0.6 or something. So I'm watching it. It should go up to 1, and then it should immediately drop back down. Please. Perfect. Okay, it's going back down. Wonderful. Okay, so while this is generating, I will be right back, guys. So give me just a second. Yeah. 1 second. Okay, I'm back. Give me just a minute. Yeah, okay, so I should be back. You should be able to see my face again, I think. Hope everyone's having a great day. And let me check really quick to see what's going on. Perfect. Okay, so let's go ahead and play this video, and I think everything should be great. MPV here. So it grows up, and then it grows back down. I mean, it still shows the scaling as you would expect. So I think this is actually totally fine. Let me... How low does it go? It goes down to 0.7. Should go down to 0.7, I guess. Yeah, 0.7 is as low as it goes. Perfect. That's totally fine. So I think this is actually how we want to do it. Let me do one more of these kind of zoom functions, MPV, just to make sure it's doing what we expect. Yeah, this is good. I mean, I know my bitrate's still not going to like this very much, but this is fine. I'm totally happy with that. Okay, so I'm going to do one more just to make sure it's actually doing what we expect. What happened here? What am I undoing? I don't understand what I just did. I think this is what we want. G++. Yeah, okay, this should work. Yep, should be fine. Okay, let's go down here. I don't exactly know what happened, but... Okay, so now what I want to do is modify one more of these guys. I'm just going to modify... Let's modify 1, 2. Actually... Yes, 1, 2 should be fine. Okay, so we're going to do G++ /Barnsley. And what this should do is it should go from up to 0.5, down to negative 0.5, and then up to 0 again. So that's what I'm watching over here on the left. And what it will do is it will actually take each of the Fern constituents as they move up, and it'll just kind of move them to the left and to the right and then back. So that's what we should be seeing. It is going up to 0.5. Perfect. Now it's going down to negative 0.5. And then this should be the visual that we need. And again, I'm just going to have to render all of these guys in bulk. I'm just going to have to render all of these guys in bulk tonight. So I'll make like high resolution versions of these. Well, I don't know, like I don't want to make them like 4K. I think 1080p is fine. But when I say high resolution, I mean like a higher number of points. Okay, it's going down to negative 0.5. Oh, no, it's actually... Oh, yeah, no, it's going down to negative 0.5. I'm actually going to do one more after this is done to make sure that the scaling up to 1 and down to 0.7 works for the other scaling case which we have, which is a scaling along X. And then, yeah, we should be good to go. So it's doing 600 frames, so just a 10-second animation, and we're basically almost done, just 100 frames left. And then we'll take a look at the visual, and hopefully it looks okay, and then we can go from there. I actually think maybe this visual will be cooler than the visual we have up in the upper left-hand corner, now that I think about it. Okay, so MPV temp video.mp4. Okay, so yeah, we just see the Fern just kind of going to the left, and then we'll be coming back and going to the right. Yeah, this is fine. Totally fine. Everything's okay. Yeah, cool. It's swaying in the wind. This is the one. That's exactly what Steve's a Steve. I made your animation for you. All right, let's go ahead and move this guy over to temp video.mp4 into Barnsley twiddle 5.mp4 over here, and let's do that. We'll have this one playing in the corner because Steve's a Steve specifically asked for one that's, you know, blowing in the wind. So that's this one. Okay, so let me generate one more video. This time I'm going to do with a fewer points. So I'm only going to do 10,000 points instead of 50,000 points. And I want to do 1, 0, which is going to be scaling along X. Okay, over here, let's run G++ /Barnsley. It should be way faster. I just want to make sure it goes up to 1, and then it drops back down appropriately for this guy as well. Yep, it seems to work okay. Now it should just go down to 0.7. And then we'll take a look at this video and it should be fine. Again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know and I'll totally address it as soon as I see it in chat. It is currently 5:30 in the afternoon, my time. I can go for until 7, basically, is as long as I can go today. Maybe I could push it till 8, but I have to be up at like 4 or 5 in the morning. So if I stream significantly past 8, I'm not going to be able to make it up at 5 in the morning. Just because, I mean, even if I go to bed immediately after I finish stream, like I go to bed immediately at 8, like it's going to take me an hour to actually fall asleep. So, anyway, let's take a look at the visual MPV temp video.mp4. Yeah, this seems to work okay. Just watching it. Yeah, this is nice. I like it enough. Yeah, it's good enough. I think the other visual was kind of cooler in a way, but also like this one's not going to break. So I'm happy enough with that. Cool. Actually, this is really nice because one like major like I guess restriction for iterated function systems is that they must be contractive. And it was something that we didn't really play with in the previous visualizations because the function was just naturally contractive. But this was nice because we actually moved on to a less contractive. We moved on to a function that was not contractive, and we showed it doesn't work. So that's kind of cool. Can't decide whether I love or hate the terminal font. I don't care. I specifically like this font because it's a bitmap font, and bitmap fonts look a lot better than not bitmap fonts. So it's what I use. If you don't like it, totally fair. Like I understand. It's just what I like and what I use. So most terminal emulators no longer allow you to use non-bitmap fonts for your videos and stuff. So I had to kind of switch to Xterm and stuff like that. But after that, it's fine. And like sometimes Unicode characters are a bit of a pain, but it is what it is. Okay, so we've got one more visual to do, and let me just go ahead and do MPV Barnsley star .mp4. Okay. So now we have one more visual to do. And the visual here that we're going to be working with is basically a visual of each of the 4 functions for the Barnsley Fern in action. Right now we have it with a random distribution of points. And we show that, one creates a stem. The next one will essentially move kind of up and a little bit to the right. The next one will create I think this one will rotate a little bit to create your left leaves. And the last one will rotate a bit to create your right leaves. So give it a second, and this one will rotate a bit to create your right leaves. Now, these are cool, like you can see with the random distribution of points, like kind of what's happening. But the issue with these visuals is that, well, quite frankly, because it's not directly the Fern, it's kind of difficult to see exactly what it's doing. So I want to redo these visuals, except put the Barnsley Fern into it. Instead of doing a random distribution of points. So I'm going to basically create the same function that we created to make these visuals, except this time I'm going to read in a distribution of points, or maybe just create a distribution of points that is the Barnsley Fern, and then do the transform to those points. It's not going to be the prettiest function ever. It's like, honestly, if I was writing this and it was going to be like rigorously reviewed and people were going to like tear it apart and stuff like that, I would not write code like this. But for now, because I want to get a video out, I want to get content out, I kind of feel let's just do it. And be happy that we have anything. You know what I mean? So, let's go ahead and create that function. So right now, I'm going to modify the Barnsley transform function. Why are you doing this? I don't know if that's like a threatening, why are you doing this? Like, why are you doing this to me? Or if that's like a, why are you doing this as in you're genuinely curious? Or this is a, like, you know what I mean? But in general, Kuski998, thank you so much for following. I don't really know how to answer that question. Because there's actually a bunch of different ways to answer that question, right? So on the one hand, yeah, we're making content for the algorithm archive found here, also making content for YouTube, also making content on Twitch. Although admittedly, the Twitch content is, maybe a bit, it's not as popular as the other stuff. The other answer is that we are doing an active research project where we are going to be looking into basically fractal compression, which is a way to turn any image into an iterated function system, like you see in the upper corner. That is an iterated function system, in order to compress the image. And the idea is that I think that there are methods. At least I think I've come up with a method that can beat modern fractal compression methods, at least in terms of speed, and also I think in terms of performance. So it's something that I wanted to research for a while, and now it's time to do it. then the other answer to that is that, let's see, we're doing this for fun or for work. That's another question. So the answer to that is actually kind of a bit of both in a way. So right now my work is I'm being contracted through 3 Blue 1 Brown to make content for him online and stuff like that. But also I have my own content, right? And I'm making enough money that I can sustain myself if I lived in Alabama off that content. But it's not enough that I would be able to live anywhere else. And so I am trying to turn this into a job. I want to be an independent researcher and make content in that way. And it's stuff that, I don't know, I kind of feel like it's a bit of both for fun and for work. And then there's also the question of, a question to you, which is, I don't really know how to answer, but like a lot of times people ask the question, like, why are you doing this? It's kind of like weird. It's like, how do I put this? Like, if you see people streaming on Twitch and they're like playing a video game, you're like, most people don't ever ask that question. But like, if you see people streaming on Twitch and they're streaming programming, then for some reason you see people asking that question, which is why I have such a weird response to it, because I don't really know what answer I'm supposed to give, you know? Because on the one hand, I'm kind of doing the same thing that every other streamer on Twitch is doing, streaming on Twitch just because it's kind of fun and hopefully it will turn into something, right? And so I don't know. It's I don't know, kind of a weird question to ask, you know? I think specifically it's weird because in the makers and crafters section and in the art section and also the programming section and stuff like that, there is a group of people like who are only streaming because they need to make content, like they need to make a game or they need to make something to sell. And so I think that's why the question comes up, you know? But anyway, it's just, that's why I never really know how to answer it, because I don't really know like exactly what answer people are looking for, you know? Are they looking for the project that we're making? Are they looking for, like, I don't know, you know? I don't know too many streamers that actually stream to learn things, except for maybe like Enceladus or something. Maybe I missed like a whole bunch of streamers, but most of them are usually streaming to make something. And I don't really watch gaming streamers, so I don't know. Maybe they are like learning routes or something for like speed running, and that's like the majority of what people do. But the only gamer streamer I watch is, well, I watch a few like Guild Wars streamers sometimes, but not regularly. Yeah, actually, very rarely, in fact. Oh, and Ring Fit. I've watched a few Ring Fit streamers as well, because I like Ring Fit. It's a fun game. Okay, so let's go ahead and make this function and go from there. I'm sorry that I ramble a lot. Like, really, I should have put the Rambleo screen up when I did that, but I just didn't. So, you know, deal with it. Okay, so we're going to take that Barnsley transform function, and we are just going to copy it. What do we have here? Premature optimization is the root of all evil. That sounds cool. Yeah, I'm actually really looking forward to the end of this research project, because actually we found out the other day, I think 2 days ago, when I was just reading some papers online, that some of the questions that we were asking in order to solve the fractal compression question and all this kind of stuff were actually active research areas. So active, in fact, that there was a paper published just a few months ago answering like the exact question that we were asking, which is, you know, how to tell if you're attracted to the Sierpinski triangle versus some other attractor, right? Like, for example, you could have a point in space, and the question is, what attractor is this attracted to, right? Is it the Barnsley Fern? Is it the Sierpinski triangle? Is it something else? Who knows? And this question was answered in a super mathematically heavy way that I couldn't fully understand. And yeah, I'm happy to go through that paper as well and kind of, I don't know, it's a lot of stuff that's happening in this field. And it's weird because like it kind of died for like 20 years and I thought that no one was looking into it, which is why I thought it was a safe bet to do research with. But no, it turns out it's quite active. Anyway, that was kind of a ramble session again. I need to stop the whole ramble sessions. Okay, so I'm just going to grab this guy and I'm just going to copy it and paste it up here. Ah, shoot. I did not do that. Let's go here, paste it here, and we're going to call it, 1 second, the Barnsley Fern transform. Okay. This function creates a Barnsley Fern. Okay. And uses the chosen transformation from the Barnsley Fern. Okay. Well, sometimes I try to type, and sometimes I fail at typing. That was the case there. Here. There. Okay. So what are we going to do here? The first thing we're going to do is, what we did here is we created a random distribution of points. So what I'm going to do is make it so instead of a random distribution of points, I'm going to make it so this distribution of points is the Barnsley Fern. So we're just going to create the Barnsley Fern, and then we're going to create the transform for each of those ferns. So for I is equal to 0, so I actually want this to be I equals to 1, 1, and then I'm going to say points PTS of 0, 0, not O, is going to be equal to, what do I want here? Points of 0 is going to be equal to, I think it's just 0, 0 should work. I don't think I'm too eccentric, am I? I mean, maybe excited about certain things I would get, but eccentric? What does eccentric mean? Eccentric. Hey, Husky, how are you? Oh, actually, I did some HTML today, Husky. Not on stream, but maybe on Monday I'll be doing some HTML for you. So, you know, if you happen to join on Monday, you might be pretty excited. It might be your stream for the first time in like 4 years. What does eccentric mean? Let's see. Deviating from conventional or accepted usage or conduct, especially in odd or whimsical ways. Deviating from a circular path. Person that behaves in odd or unusual ways. I'm not that unusual. Man, you just called me weird. But no, I don't know. Maybe I am eccentric. I don't know. I'm using C++ for this because the visualization library is in C++, and there isn't as many. There aren't as many good visualization libraries in other languages. No, honestly, Husky, you were like one of my first followers, like literally one of the first followers. Like back in the day when I wasn't even in the apartment that people knew me from in Okinawa. I was in the apartment before that. You were probably there for the memes when like my wall color was like this weird shade of green, and like the meme was like that wall color was like a special wall color for some reason. Like, man, back then we had like Crams Facil like joining us. Gustorm was there. Actually, Gustorm was there quite regularly. BPath. Oh man, good times back then. And then I kind of stopped streaming for a bit, and now I'm streaming again. I don't know. I have this kind of like back and forth with streaming all the time. And I really just need to say, you know, like focus on something, you know? Okay, so how am I going to do this then? I think I can just say the following. So I think I can say PTS of I is going to be equal to apply Barnsley of PTS of I minus 1 of the B function. Yep. And then we can remove this guy, and we can remove that guy, and then we have vector location. Should be fine. So, yeah, we need to change the world size because it's going to be a bit too... It's not going to work. But that's okay. We'll get there one step at a time. Monday prediction, npm install Barnsley Fern. We're not going to do that, unfortunately. The Monday stuff would actually be working on 3 blue 1 brown content. I'm going to be mocking up one of the articles that I'm making for him. And essentially the question is, like, I don't know, like, it is how to make it as visual and like understandable to the widest audience as possible. So we think that potentially streaming this, admittedly, I don't get too many viewers on my stream, but we get enough that we can have some sort of discussion about like what actually like makes sense from a pedagogical point of view. I'm good just finishing up my master's thesis. Can I just say that Codalab is awful? Thank you for listening to my TED Talk. Oh man, like there are so many bad frameworks. I don't know Codalab, but I can assume, well, okay. Anything with lab in it makes me think MATLAB, and it makes me worried that it's a MATLAB thing. And if it's like MATLAB but worse than MATLAB, oh boy, that sucks. Speaking of which, I was thinking about rebranding to Leos Labs instead of Leos OS or Simuleos. I might keep the Twitch stream Simuleos. I like Simuleos in the same way that I like Scribbleos and stuff like that. Was the topic of the 3 blue 1 brown article video? It's basically updating the essence of linear algebra to be written. I'm not going to go into all the details of what we're planning with that, but it's looking promising. We're actually pretty happy with that. Phil Shog, thank you so much for following. Really appreciate it. Did you know that the company domain for the Cook Islands is co.ck? Cook. They missed an O. Oh, no. If the C is an O, no, then they're fine. Yeah, that's pretty close to cook. So is it cook.cook? Is that what they were going for? Or is it just like site.cook? Is that what they were going for? Could be. Okay. So now we have to figure out the let's see, what am I doing with my life? 1 second. So now we have to find the Barnsley function. So bf is equal to 0. What am I doing? I need to just select an integer. So I'm just going to do dd, I'm just going to say int bf is equal to 0. That's going to be our Barnsley function. And then in here, we just need to put in the logic. Just hear me out. I know I'm an idiot. Just like, forgive me, please. Okay, so let's go in here. Right, here's our else if statements. I just realized that this is like horrible. It's awful. Like, this is just awful. Let me fix this really quick. I'm going to move this down to the next line here. Perfect, just barely fits. Move this down to the next line. And hopefully I can move this down to the next line as well. Oh, I hate this. I hate this so much. Okay, it is what it is. Okay, how many lines is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yank, 15, yank. And go back down to this other stuff. 1 second. What am I doing with my life? I don't know. Why do I even ask that anymore? Okay, nope. No, yes, yes. So I'm gonna paste it here. dd. That's wrong lines. I didn't even look at the lines before I copied them. Okay. Twiddle. Affine. This is what I need. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fern here. And then we're going to paste that here. Okay, so all I want to do is modify this logic here for x. 1 second. To make it so we select the Barnsley function based on, you know, some random value. So here we're going to say bf is equal to 0, yank, paste, paste, paste. So it'll be 1, 2, 3. What does YES spell? Yes. Am I in trouble? Like, did I do something wrong? Okay, so let's go here. Apply Barnsley. So now the next thing I want to do is create a random value. So we're going to say R&D is going to be equal to rand. Double. I think I need to do ran modulo, like modulo 1000 divided by 1000 or something like that. And I think I need like a double or something. What does EYES stand for? Eyes? Am I doing something wrong? I think I can cast it onto a double like this. And that should do. Yeah, that should do okay. And so this will give us a Barnsley function. We should be able to select here. Now you figured it out. I've seen that one before. So it's not that I figured it out. Let's go here. And now let's go down there and let's modify this so it's Barnsley transform, yank paste, and we're going to try the Barnsley Fern transform and see how it goes. Perfect. Okay, so we're going to try doing the last G++. It's probably going to break. It didn't break. Hey, maybe this guy. Crap. And then it seg faults. I was like, man, maybe this guy actually knows how to code. I was gonna say, like, you know, for the first time in 5 years, you know, I write code and it compiles, no problem. And then seg fault. It's like, you know, just like smacks you in the face. Okay, let's see if we can figure this out. Up here, Fern, twiddle. Okay, I don't know how it seg faulted. I can open up GDB, but I'm too like, how did it seg fault? How do we even get a seg fault? So we must have like grabbed an element that didn't exist. Points of I. Okay, let's just open up GDB then. GDB, Barnsley, R, backtrace. Does it give me a line number? Oh, GDB's changed, man. I I was... Don't they normally give you a line number? Okay, well, I obviously grabbed an element that doesn't exist, right? Screw it. Screw this. Control D, yes. Go over here. We're just going to output I. That's what we're going to do. std, cout, I, new line. Try that again. G++, /Barnsley, goes to 999, then segfaults. Wait, are we segfaulting the next loop? Maybe we are. 1 second. Print line. Sorry, std cout. No one sees this. G++. /Barnsley. Oh, where are we segfaulting then? How are we segfaulting then? Do we not have enough frames in the world? Balls? Do we not have points.size? I balls. How do we not have enough? No, we do. Where are we segfaulting? G++ /Barnsley. We're segfaulting in there. How though? std cout I, new line, G++ /Barnsley. We only have two values, points and balls of I. Are we... How are we... Okay, well, let's just do yank, paste, paste. All right, points of I. Balls of I. Oh, is this gonna work? I think we need maybe .x and .location.x. Maybe this needs to be a pointing to or something. Let's see what happens. I think it's a smart pointer. Yeah, so I think it needs to be... Oh, well, that's screwed up. Try that again. Struct ellipse has no member location. Maybe it's just location. Okay, that seemed to work. ./Barnsley. Okay, so why doesn't it exist? What's going on? Okay, so balls of I doesn't exist, but it does exist because we just used it in this loop up here. Let me see if I still have the GDB messages up. I do. There's no way I still have the GDB messages. But let me just try running this then. So we're going to run GDB. GDB Barnsley here. Run that guy. Return. Backtrace. Barnsley Fern Transform. GDB. Info? I don't remember how this works. Ah, crap. I don't remember how GDB works at all. Did it even segfault? Yes. Okay. Segfault. In Barnsley Fern, did you give me a line number? No, you didn't. Backtrace here. Does anyone remember how C++ works? I mean, like, someone probably does. Okay. So, okay, but we know it's probably the ball location, right? So let's go up here. Let me just try outputting the ball location in this guy, in this loop in here, and let's see if that works. So Control D, yes, G++, /Barnsley. Yeah, works just fine. So how, Yep. Okay. So... we created our vector. We apply Barnsley points of I with the transformation type. We applied Barnsley, and then in here... The ball just doesn't exist for some reason outside of this scope, and I don't understand how it... So, okay, here's what I don't understand. So let me try yanking this, pasting it down here, and saying this is balls of 0. Okay, so now we're going to g++ dot slash Barnsley. That didn't help because I don't... Okay. Oh, no, that did help. Ball 0. Okay, hear me out. And then here we're going to say ball of I. Okay, so now we're going to run g++. Balls of 0. I forgot... What did I forget? I forgot the little whatever lesson symbols. Okay, g++ dot slash Barnsley. Okay, so here we see ball whatever. We have all the balls here. They're all working. But then for some reason when I leave this scope, it doesn't work anymore. And I don't understand why that would be the case. Yeah, I don't understand why that'd be the case at all. So I must have done something dumb because I literally grabbed the Barnsley transform function. So let me try the Barnsley transform function again and see if that one breaks. Okay, g++ dot slash Barnsley. Yeah, this one seems to be working just fine. Okay, well, let's see if we can figure out what the difference is between the two functions, because at this stage I'm lost. Okay, you don't use location in the upper part. Vector location. Let's see, vector location. Balls is make shared. It should be there. It should be right there. It should be with the make shared in here. So we create the vector location, which is where the ball exists, and then we put it in here as location. But then again, it should work. Yeah, I don't understand why. Okay, you know what I might do? I could try a line-by-line comparison, or I could just like rewrite this function, because I didn't modify. I mean, the function is basically the same as the other function, with like very small modifications. Int transformation type. Okay, so let me just go here, vi Barnsley dot C++, and let's go to transform. Yep, and almost. Quad transform, Fern, there. Okay, so let's just take a look at this guy. So points, and let's go over here and let's just put them line by line. Well, okay, well, almost line by line. I was off by a few lines. Okay, there we go, line by line. And let's just try to figure this out. So points n, shared ellipse, balls n, add layer, totally fine. So here I did modify it slightly because I said points of 0 is going to be 0, 0. So let's just go up to the for loop, shall we? So the for loop here is for int. Okay, I understand now. I didn't initialize the first ball. Yep, I got it. So let me just grab this guy, and let's get that first ball initialized. Yep. Yep. 0 to 30, yep, should be fine. So we're going to initialize that first ball, because that's what I did wrong. Okay, that was subtle. That would be like Okay, I don't feel as bad for not catching that one. I mean, I should, but I don't feel so bad, you know? Okay, so here we're going to go initializing. Okay, so here we're going to say initializing first ball and point. Okay, so then what we're gonna do, I probably should have done this a different way. What I probably should have done, okay, no, let's not reuse code, shall we? So we're gonna do the following. We're gonna say, in here, we're gonna go, as we should. And then for this one, we're gonna say, if I, I equals 0, we're gonna just say point is equal to. And then else if, else probably is fine. Yes, that's what we want in there. So if this is equal to 0, then we're going to say point of 0. PTS of 0 is going to be equal to 0, 0. Okay, and then let's go ahead and put all these guys forward a little bit. Okay, and that, I think, should do it. Go down here, do the Barnsley Fern transform instead of the Barnsley transform. And now we're just going to run g++/Barnsley. Is it working? Yes? I guess? Okay, nice. See out. Remove all of these guys. Remove this guy and that guy. This line in here. And let's see what happened. So mpv temp video.mp4. Cool. It works. We're looking at like a very weird section of space, but it works. Okay, so now all we have to do is zoom out so we see the entire fern. Good. John Cole RT, thank you so much for following. Really appreciate it. Okay, give me just a second, and let me think about what we need to do. So again, it worked. Like we have something that is working. The only problem is we're zoomed into like this section of the fern in here, so we have to zoom out to make sure that we're fitting the entire space. And that's literally just a magic, like figuring out what the magic numbers are. We know what the magic numbers are because we've been using them elsewhere. I hate magic numbers. I really should have done this better. I wrote this code like 2 years ago though, so whatever. It's just a matter of, you know, getting back into it, writing better code as you can. To Chaos Game, Barnsley Twiddle. What is Barnsley Twiddle? Yeah, this is what I want. Okay, so we should have magic numbers in here then. Where are we? Yes, vector location is this guy. 200. Is that right? World.size.x times 0.5. Yeah, I think that's what I want, right? I think. Well, let's just see what happens. All right, so where's our next location? So leaf fern transform should be in here. And where do we define our locations? So we define our locations here. So I think if I just paste this in here and we take a look at the difference, isn't that the same? World.size.x times 0.5. World.size.y times 0.5. Oh. It looks the same. Oh, the 200 and the 500. That's the difference. Sorry. So we're going to change that to a 5, and we change this to a 100. Okay. And we're going to do that for the other magic numbers down here as well. 5 and 1. 5, and 1. 1, and let's see if that does it. So now we're going to run g++/Barnsley, and we're going to see what it looks like. Hopefully, we should see the entire fern being compressed into a single point. Everman, gotta sleep. Thanks for the stream. Yeah, thanks so much for coming in. Hopefully, I'll see you around next time. And thanks for the follow, by the way. Also, I missed a couple follows here. Random and also the Bite Man. Thank you guys so much for following. Really appreciate it. Okay, let's take a look at MPV. And we see the entire fern, and it's compressed into the little bit there. Okay. So now what I want to do is see what happens if we increase the number of points here to maybe 10,000. We might want to make the point size slightly smaller as well. But I just want to see if we can do larger functions. So I should have timed that. Let me do Control C, and now let me just type in time, and then /Barnsley. Okay, we're going to see how long this takes. Just to see how it scales, you know, the last one took, 10, 20 seconds. So this one should take, I don't know, 10 times that, so maybe a minute. We're just going to see how long it takes. Maybe it won't take that long. I don't know. We're storing a lot of data, though, now that I think about it. Let me open up HTOP really quick, just to make sure I'm not using too much memory, but it should be fine, right? Like, we're talking about float 64 values, 2 times float 64. What's a float 64? Float 64 is 8 bytes? Am I dumb? It should be fine. Yeah, we should have enough memory. Okay, let's take a look at this guy. Nope. MPV. Okay, so there's our Fern. Good. I'm going to make the point size slightly smaller. First time watching, is this just playing around with fractals with that Fern-like structure? In a sense, yeah. I mean, it leads into a larger research project. It's related to a lot of stuff that we're doing with the algorithm archive and all this kind of stuff. But in a sense, yeah, we're trying to kind of better explain how the Barnsley Fern is generated via iterated function systems, which is a type of fractal. And what this will do is it will allow us to, in some sense, generalize to other, like, fractals of a similar form, in a way. And that's really helpful for some of the stuff we're going to be doing in the future. You know, we want some intuitive grasp for how these function systems work. And the hope is that by doing this, we do get a better intuition as to how these could work, you know, and how each, like, transform does its thing and all that kind of stuff. Okay, let's do Fern here. And I think what I want to do is modify the size of each ball. So here we're going to do ball, add animator. I think I want to change this just to 2, right this. Go over here, and we're going to try G++ /Barnsley. It only took 30 seconds, so we can wait for it. As for cool, any point of using C++ versus a different language, the reason I'm using C++ is just that this is a language that has the visualization software in it. We could use a different language. Like, for example, I'm more than willing to use Julia as another language that I use a lot. Python, I've used that a lot for a lot of visualizations as well. It's just the visualization library that I'm using right now is in C++, and I quite like it. It's a lot easier to use than the other visualization libraries in other languages. Like, for example, I could use Manum, the math animation library, which is made by Grant, 3 Blue 1 Brown. But for me in particular, I don't find it super intuitive because I'm not used to, like, heavy object-oriented programming. So it kind of, I don't know. So there's a Fern, goes down to a single stem. Perfect. Okay, let's take a look at the other functions as well. Okay, so now we're going to do the next function, which will be 1. Go over here, run G++. I'm not going to keep these visuals. I just kind of want to look at them to make sure this is what we want to do. The visualization library that we're using is GathVL. I think I posted a link not too long ago. Yes, this one. It's written specifically for the algorithm archive work. So it's written by a member of the community named Gathros a few years ago now, and I use it a lot for a lot of my visuals, both on the algorithm archive and also on YouTube. Let's go here, MPV, work, and yes, exactly what I wanted to see. Perfect. Yes. Okay, so now my question is, should we have 2 sets of dots? Should we have 2 sets of dots that... Okay. Because what you just saw there, this is perfect. This is exactly what I wanted to see. Wonderful. Okay, so here we see this transformation bringing the entire structure up and to the right a little bit. If we had the old set of dots available, right? If we had the old set of dots available, what we could do is we could have these dots kind of move up and to the right and kind of change their color to, like, pink or something. I don't know, like, change their color as they're moving up, maybe to red. Yeah. Let's see what that looks like. Because I think that's actually, okay, well, let's take a look at the next animation. I'm getting ahead of myself. Let me see what the next one looks like. G++, /Barnsley. But I think having both sets of dots there would really help with this visualization. Because again, we're trying to see what each transform actually does. And this really does show that. And that was really good. I quite like that visual, actually. Like, the visual in the upper left is cooler, don't get me wrong. But this one's more informative in a way. Let me see what this one does. And if it does what I think it does, it should make a leaf. All right. Perfect. I'm actually unreasonably excited for this, guys. Like, way more excited than I should be. And you guys are totally right. We do need 2 sets of dots. So let's create the 2 sets of dots. Fern. I'm unreasonably excited for this, actually. Like, it's way cooler than I thought it would be. Like, it's gonna look amazing. Like, this is gonna be like one of my favorite visuals. I make a lot of visuals, so like maybe not my favorite visual, but like it will be a fun visual. Okay, so let's go here to Fern Transform. And I want to create 2 sets of balls. So we're going to do yank, paste here. So balls, new balls. Maybe I should call them blue balls and red balls. What's green? Okay, we'll just do balls and new balls. That's what we'll do. Okay. Now what are we going to do? We are going to create the ball. We're going to have the ball color. And what I want to do is grab yank, 3 yank, and paste. Okay, so these are going to be new balls. Oh, no. Oh, it doesn't. No. No, I just suck so much. New balls here. Okay, so now we have the ball location. We're adding an animator for it to be created, which is great. Let me move this down to the next line. And then what I want to do is I want to leave the old balls in place and move the new ones into place. So we're going to do here, location before, location after. And so this is only going to be new balls. Screw it. New balls, add animator. And then we're going to have the new location, the old location. And what I'm also going to do is change all of the colors just to be red. So I'm going to add a color animator and change the color from blue to red. Yes, that's what I want to do. World add object balls. And then I also want to do new balls. New balls. We are coding visualizations. So like, for example, we just made this visualization of like, you'll see in just a second. So if you see that visual in the upper left-hand corner, we're making visuals like that in order to better understand how to create this mathematical fern. That's what we're doing. So we should be able to run this. So now I want to do, add a color animator to this, yank to yank, paste, and then add animator, color animator. Okay, and then what we want to do is 60 to 120 balls and change this to color. Okay, now we should have the ball color as this guy in here. Do I have to keep a list of all the ball colors? Maybe, but then I want to change it to be red afterwards. So yeah, I think what I'm going to do up here is just create a color that is red, and I'm just going to say color. How does C++ work? Am I allowed to do... I'm so sorry. Can I do the following? Maybe I can just do the following. This will probably break. But, you know, we can give it a shot. Red. Sorry. Color. Red. Green. Blue. Opacity. Okay. And this one we're going to say is color. Color. 0101. All right, let's just see if this compiles really quick. It does not. It's because this is apparently CLR. That compiled, which is great. So now the next thing I want to do is, I don't have, oh, yes I do. So I can say, hear me out. New balls of I pointing to CLR. Okay, let's try that, G++. Now let's try the visual. Please work. Okay, so what we should see is we should see the Barnsley Fern. Then we should see the application of one of the functions for the Barnsley Fern, taking the fern and moving it over to the left leaf. That's what we should see. It should be really cool, I think. It might be ugly. I have no idea. We'll see what it looks like. Okay, it's done. MPV. Here's the fern, and almost. So close. Okay. I actually think I want it to be yellow as well. Red, green. I think I want it to be yellow because I think yellow fits better with the theme. And world add object, balls, new balls. Why Where is it? Where's the other set? I have 2 sets of balls, and I'm adding them both. I'm adding balls and new balls. But then the old ones are gone. They just... maybe red is the right color. I don't know. 1 second. Let's try red first, and then if it looks ugly, we'll fix it from there. Vector location after new balls of I. Balls of I is going to make sure vector add animator ball.size vector 0 0. The location is the correct location. They are being put at the right spot. I'm adding the right objects, I think. Points of I. Okay, what happens if we do the following? Let's just comment this out. And let's do G++ ./Barnsley, and let me see what this does. If this still creates the Fern, so right now we're not adding the new balls. So we have the old balls and then the new balls, and the new balls are the ones that are rotating, right? And so I just want the Fern. I don't want the rotation. So let me see what this does. MPV, we create the Fern, and nothing happens to it. Okay. Oh, maybe. Okay, maybe I understand now. We want to do this on layer 2. Maybe because I was drawing them on the same layer, they were being overwritten. So G++ ./Barnsley, hopefully is the visual we want. I'm unreasonably excited for this visual, by the way. Like, it's just more excited than I should be. Like, way more excited than I should be for this visual. I don't even know why I'm this excited for it. 1 second, I got a notification I have to take a look at. A couple notifications, actually. Let me, while this is rendering, give me just a second. And 1 second, and then, sorry, and good. Okay, MPV. So here we have that, and dang it, where are the old dots? Yeah, so this visual is for a number of different things. It's for the algorithm archive. It's also for YouTube. Also, it'll turn into a research project, all this kind of stuff. So it's for a number of different things. It's right now, right now we're just trying to learn more about it. But tomorrow, hopefully, we'll be writing a chapter for the algorithm archive. And then hopefully the day after that, we'll be putting a video out on YouTube. It might be a bit... I might be a bit short-sighted to say we can get a video out on YouTube this weekend, because it always takes me way longer to make videos on YouTube than I believe it should. But really, I do think this is like one of the better... I mean, I think it's a really cool visual. I'm really looking forward to it. It's just for some reason, why is it not working? Okay. So, what is the problem? Again, we have the old balls in the background. They're drawn on layer 1. Then we have the new balls drawn on layer 2. For some reason, when I draw the old balls, which are it's just like the green fern in the background, I want them to stay in place and I don't want them to move. So if I only draw those, and I don't draw the new ones, let me also decrease the number of points so it just takes slightly less time to make. Okay, so here we're going to try G++ ./Barnsley. It should take way shorter of time to make, I think. And so I'm not drawing the new balls. So basically old balls, new balls that are being transformed. Okay. So when I look at this, we have the Fern being generated. Really low resolution Fern, I get it. But all the points are there. Okay, perfect. So now what I want to do is I want to only generate the new balls. And I'm not going to generate the old balls. Okay, and if we go over here and we run G++ ./Barnsley, we should see only the ones that are going to be doing the transformation. So just the ones that turn the Fern into the little side Fern. MPV. Oh, we see nothing. Why do we see nothing? Okay, that's good to know. That's good to know. I don't understand what's going on. Right, I don't understand what's going on. Aha, that's what's going on. I'm pointing to the wrong thing. Let's go there. Write that. I'm modifying the old ball's color and location. So now let me see what happens if we do this. And also we have to go in here and we have to modify this so these are also pointing to the new balls. Okay, in principle, now we should see the transformed points. So we're going to do /Barnsley, and we should only see the transformed points. And then I'm going to try a visual with both of them, and we should be able to see both of them. MPV, transform, perfect. Okay, so now let's try both of them, right? G++ /Barnsley. I'm super excited. It's the dumbest visual I've ever made, and yet, well, it's not the dumbest one. I think it's still pretty cool, but like, okay, so now we're going to try MPV. Yes! Yes! Okay, there we go. Perfect. All right. I am unreasonably excited for this. And now we're going to add an order of magnitude more points. G++ /Barnsley. And what we should see is the application of the third function of the Barnsley Fern, which should create the left Fern. So what I'm going to do right now is I'm going to show all 4 transformations. One that creates a stem, another that creates successively smaller ferns as we go up and to the right, another that creates a left leaf, and another that creates a right leaf. Right now I'm showing the left leaf function, but there are 3 other functions to show. And hopefully this looks really cool. I'm really looking forward to this. Again, unreasonably excited for this. I don't know why I'm so excited. But we created some just spectacular visuals today, guys. Like, just beautiful. Okay, MPV. Look at that. Okay, the red's a bit bright, isn't it? Yeah, the red's a little... The red might be a bit too much. Let's let's make the red a little bit less. Okay. It does look a bit bright, doesn't it? Yeah. Yeah, it definitely, yeah. Well, does it though? I mean, like, let's make it a bit smaller, right? Am I just being a bit too picky about that? Or do you guys also think it's a bit bright? I don't know. I feel like it might be a bit bright. Yeah, so let's add something to this color. So it's red, and we're going to add just a little bit, 0.25 here to the green and the blue. Okay, let's try this. G++ /Barnsley, and we're going to give it a go. And then we're going to see what that looks like. We're so close. We're going to get these visuals done. But no, these are like really good. I'm really liking these. Yeah, I'm really liking these. I think that these are not the best visuals ever made, but they're pretty good. Could you reduce the alpha value of the red? I could. Yeah, that's actually probably what I should have done, but I didn't. I increased the other 2 colors. So let's actually just decrease the alpha value to maybe 0. Oh, hello. Try that again. Let's try 0.75. Okay. Let me see what this one looked like. MPV. Yeah, we definitely just decrease the alpha value. That's the way to do it. You're smarter than I am. Write this. Go over here. Run G++ /Barnsley. Give it a go. And this should be better. I needed something that looked darker. So what I should have done is I should have decreased the value of the red, not increased the value of the blue and the green. That's what I should have done. But decreasing the alpha value, I think we'll do the same thing. So give this a second, see what it looks like. And then we'll do the other 3 transforms. Yeah, no, this is good. This is really good. Like way better than I thought it was going to be. Why do though? Why do anything? Why are we living? Why? Oh, okay, that got really dark. I'm sorry. MPV. And that did nothing. No, that's okay. Screw it. Apparently my alpha values just don't work. Let's change this to 0 and let me just see what happens. G++ /Barnsley. This is so cool. We are all about the Fern down here. Oh, you're in New Zealand. Nice. Everyone I've met from New Zealand is just an amazing person. Great work. Any optimizations you're considering to reduce the runtime? Yes and no, not necessarily for the visual. Right now, I don't care so much about the visual, but for the actual project that we're doing, which is going to be for Fractal Compression, yes, we definitely have ways to decrease the runtime there with GPU acceleration, all this kind of stuff. Right now, the visuals are being done via a library that's using Cairo in the back end. I don't really care so much about that. I mean, we'll just let it run overnight. I'm not too worried about that. Anuvrat S, thank you so much for following. Really appreciate it. What kind of simulator do you use? It's not really so much of a simulation. It's more of just a, what? happened there? What? I don't understand. Okay, I'm gonna screw it. We're gonna leave the alpha value as 1, and we're gonna drop this down to 0.75. I'm also gonna do something else just to make it so the simulation is done faster because we just have too many points. Write this, go over here, and we're gonna run g++/Barnsley. So it's not so much of a simulation. We're using C++. It's called an iterated function system, also known as a chaos game. If you go to the algorithm archive, 1 second, here you can read more about iterated function systems. And we're going to be writing a similar chapter from there. Get a Simuleos, get CM, follow Simuleos. Mignon Tech 14, thank you so much for following. Really appreciate it. Nice message, by the way. So let's go into MPV. And that probably is better. I'm so sorry, guys. Give me CLR. Here. Nope. 1 second. Here. Okay. Let me see what that looks like with more balls, because apparently it only really looks bad when we have a lot of points. g++/Barnsley. We're just looking at the same visualization again and again. I'm just modifying the colors by a bit. I do understand that if I was using a better a better drawing software, it would be better, but it's fine. It is what it is. Like right now, I'm not too worried about optimizing the runtime of this. Because again, I'll just let it run overnight. It's fine. Render times are always long for this type of thing. I probably could have been using some shader logic or something as well, but I just don't care. I'm not going to write the code. There's no reason in optimizing the code here, you know. Which animation library are you using? We're using one called GathVL. It is a visualization library made specifically for our stuff. MPV, and the red is just too red. No matter what we do, it's just too red. Okay, let me just screw it. What am I doing with my life? CLR. I just don't know how to fix this. g++/Barnsley. It doesn't matter. I'm just being a little bit too, just slightly too annoyed. Gokberg, thank you so much for following. Really appreciate it. I need to be I just need to, I just need to not care, and everything would be fine. If I just didn't care about the red being just slightly too red, we'd be done with this by now. But I apparently care a bit too much about it. This visualization this one should be fine, right? I'm almost positive this one will be fine. If it's not, let me just do the other visuals anyway, just to make sure that they look like we expect them to look. MPV, please, 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 please. Okay, that's better. Yeah, that's better. I think I realized what the problem is. Yeah, I now understand why the red looks so much more red. It's actually no brighter than any other point on the screen. It's just the red looked so much redder because there's just a much higher density of points in that area now, right? And so because there's a higher density, it looks more red, so it kind of, yeah, it kind of stood out more. Okay, and that's why the alpha value trick didn't work, because the alpha value trick didn't take into account the fact that we have more points there. So if you have 0.5 alpha value, well, that doesn't help if you have two red dots on top of each other, which is what we had. Okay, I get it now. Well, there was some weird rendering issues going on as well. Okay, so let me move this over to this directory. And I'll take a look at the other functions. So move temp video.mp4 to Barnsley, and we're going to call it Fern Transform 0, which one is this, 2? Dot MP4. Oh man, I'm great at naming. This is how you know I'm a pro programmer. You know, if you look at my naming conventions. Okay, so let's try all the other ones. g++/Barnsley, and we'll take a look at all 4 transforms, and presumably, this should look pretty good. Let me get some water. But yeah, really excited actually. I know I said I'm really excited multiple times, but yeah, the visuals are turning out better than I anticipated. I knew they were going to be good and they were going to explain everything pretty well, but I didn't think they were going to be this good. You know, I'm actually pretty stoked about it. Yeah, we got some good visuals today. This will make a good video. Like, even if no one clicks on the video, because no one's going to click on the video, but even if they don't click on the video, we still have some pretty good visuals. Okay, so this one should be the operator that creates the stem. So it should just bring all the points down to the stem. Perfect. Okay, let me move this guy over here, and we're going to do TF0. And now the next one is going to be the one that creates successively smaller ferns as you go up and to the right. So this one should be here, there. Wrong. I pressed the wrong button. G++. Okay, so what this one should do is create successively smaller ferns as you go up and to the right. Give it just a second to render. And then the last one should create the leaves on the right. So we have one that creates the leaves on the left, one that creates the leaves on the right, one that creates a stem, and another that brings you successively upwards. Yeah, it's perfect. It's exactly what we want. Max M9450, thank you so much for following. Really appreciate it. Give me just a second. It's taking a second to render. So if you guys have any questions, comments, concerns, anything like that, feel free to let me know, and I'll totally address it as soon as I see it in chat. Shoot. MPV. MPV. Barnsley. I screwed everything up. I have to redo the first visual now. Move Barnsley Fern TF0 into Barnsley Fern TF1.mp4. And now let's MPV. MPV Barnsley Fern TF1.mp4. And this one should create. Yes. Perfect. That looks really good. Yep, perfect. Okay, so the next thing I want to do is regenerate the first one again because I accidentally screwed up. So we're going to do G++ /Barnsley. So we're going to recreate the stem visualization, make sure that's working. And then the only visualization we have left is the one that will create the right leaf. That's the only one we have left. So I'll go ahead and prompt that while we're waiting here. And that should be that, actually. So we'll take a look at all the visuals, and then what I want to do is kind of sketch out what we need to explain this pedagogically, like what the best way is to explain what exactly we did for the algorithm archive chapter, and also for the video. The video itself is probably not going to be as like explaining. It's going to be more like clicky. Here's like everything that we need. MPV temp video.mp4 should create the stem. Perfect. Okay, so now we're going to move. Should be up here somewhere. Perfect. And now we just have to do the last one, G++ /Barnsley, and this one should create the left leaf. And honestly, really happy we did this, because if you look at the Wikipedia article for this, like, it's quite difficult to understand. Like, when you read it, it just doesn't really make that much sense. So, it's really important that we do this, right? Because I think we're doing a lot better than Wikipedia at describing this. Tom Dabrowski, thank you so much for following. Really appreciate it. Okay, give it just a second. We're almost done, and then we have that last visual ready to go. Any advice for soon-to-be data science grad student? Unfortunately... Oh, wait, what do we have here? Kiora looks like silver fern. I don't know what silver fern is, but... Oh, might be... Actually, the silver fern must be the New Zealand fern, right? Soon-to-be data science grad student. So I don't know very much about data science. My PhD that I did was in quantum simulations with GPUs and stuff like that. I didn't really do anything with data science so much. It was all just, theoretical simulations and stuff. So I don't really have too much advice. But as a grad student, I don't know if you're getting into a PhD or if you're getting into a master's. But my general advice is that, you need to treat it like it's a job, and I don't mean that as, you should be constantly working for this company. No. I mean it the other way around. As a job, jobs are really nice, way nicer than academia. Because with normal jobs, you work 9 to 5 and then you leave, right? And that's incredibly important, right? Just have some sort of standard work-life balance that you strive for. As specifically a grad student, you're going to be constantly asked to spend, overtime in the lab, to be up at 3 o'clock in the morning to solve this one thing that other people can't do. Like, it's just constant no one cares about work-life balance in academia. And you really have to, for yourself say, I'm only going to work, 9 to 5 today. I'm only going to work, these hours. Make sure you're still putting in your time, 40, 60 hours a week, whatever you feel you need to do. But don't put 100 hours a week, every week into this project, Do what you can and waste, basically do your best not to waste time and do your best to really focus on your own work-life balance. More interesting, academics with regular work, whose job is like that, don't go into software then? Wait. Okay, for the record, I do understand that a lot of jobs will ask more, right? But what I'm saying is, for the most part, if you are working an industry job, you have more regular hours, right? Like, that's, I don't know how you could possibly argue that point. As an academic, I was constantly up at 2, 3 o'clock in the morning, almost every day, working on simulations and stuff, because that's when my simulations were done. They took 6 hours to run, so I ran them, right when I got off of work, slept for 4 hours, woke up, ran the simulations again, went back to sleep. This is what my standard schedule had, two 3-hour sleeps instead of 1 8-hour sleep session. I was constantly just trying to make sure that everything was running. I was working overtime coding and all this kind of stuff. At least with normal jobs, you can pretty much be sure that you can go in at 8 o'clock in the morning and you can leave by 8 o'clock at night. There's at least a 12-hour period where you're pretty confident that you'll be working this time, but you won't be working at there will be hours that you're not working, right? Meanwhile, in academia, it was constant, just constantly you were expected to be working. Anytime you're not working, you have to have a good excuse for that, right? There was no concept of work-life balance. Now, I do realize what you're saying, in a lot of industries, for example, game dev and stuff like that, it's probably still pretty bad, and maybe even just as bad, as I mentioned. But I'm just saying that I know there are certain jobs, and I know a lot of friends who went into software development who had much better work-life balance than I was able to have in academia. And I was in a lab that actually strove to provide work-life balance for its students, and was doing its best in that regard, doing better than a lot of other labs, for example. So I just feel though I do 100% understand what you're saying in that, a lot of industry jobs are just like that, and I 100% agree. I'm saying that, keeping that work-life balance is the most important thing, and they earn more. Academia is a scam. Oh, definitely, 100%. But yeah, so my advice is just strive to keep work-life balance. Okay, let me play this last video, mpv temp video.mp4. So this one should create the right leaf. Oh, I did the stem animation again. No way. Okay. Gotta run it again anyway. /Barnsley. I'm sorry, I'm rambling. I'm rambling way too much, and I do apologize for that. Yeah, it's fair. It depends on the place. Right, definitely. Any tips for graduate students in bioinformatics without a proper computational background? There was one other question above that I never answered. Let me get to that first, and then we'll get to this one. What's more interesting, academics or regular work? That is a very, very nuanced question that doesn't really have an appropriate answer. Academics tend to believe that their work is more interesting than regular work, right? And to some extent, maybe that's true, right? There's a certain romance to being an academic, to being a researcher, and, pushing that boundary of human knowledge forward, doing things that no one's ever done before. But then you think about it, it's well, software developers do that every day, right? When you think about it, every new line of code that people have written is technically new, something that no one's ever done before, right? Unless you're just copying from Stack Overflow or something. This concept of doing something new is not as hard to find in industry as you might expect. Now, granted, you're not publishing and there's all these other things, but for the most part, if your job, if what you want to do is just solve interesting puzzles, you can probably solve interesting puzzles in industry without any problems. If you specifically want to publish papers, then academia is the way to go. If you're really interested in teaching, academia might also be the place to go. But this weird dichotomy between industry and academia, I don't necessarily buy into. I feel like you as a human have to decide, hey, do I want to do research for the rest of my life, or do I want to do software engineering? This type of thing. Take a look at this video. Hopefully it's the right video. Yes, perfect video. All right. So let's move that over. So now we have all 4 of them. So let's move temp video.mp4 into Barnsley Fern TF3, I believe, .mp4. Let me keep answering the questions, and then we'll take a look at what we have here. Any tips for graduate? Okay, so for the graduate students in bioinformatics, I will say that you are in good company. Most bioinformaticians that I knew did not have proper computational training. I would say that what I would do if I were you is to treat the computational background that you need to get as a bioinformatician as part of your training. A lot of people will probably ask you to focus specifically on the biology, and I would encourage you to make sure that you're learning Python along the way. You're doing distributed computing. You're learning how supercomputers work. Maybe you do some edit distance algorithms, even though you're never going to have to code that properly. Learning how that works is really helpful for learning how the bioinformatics algorithms work in the end. Just make sure that you're not just using software packages. Make sure that you understand how the software packages work beyond that, right? And even if it's not Python, if it's Julia, if it's R, whatever it is, just make sure that you try to get a deep understanding of the language, and you try to learn from outside your bioinformatician bubble. You try to expand and learn how to do proper software development, all this kind of stuff. As long as you're open and actively looking for other areas to learn from, you're going to do fine. Can you do both academics and work? Okay, do you work or live? Do you work to live or live to work? Wait, do you work to live or work to live? Wait, that's the same. You said the same thing. Do you work to live or work to live? This is the question we need to ask. Well, I guess, but I know what you mean. Do we work to live or live to work? And that's a very important question. Or get a partner that does know. Right, true. Yeah, getting a partner that you work with that understands how to answer these questions is very important. I know for a fact that I taught a lot of bioinformaticians as a graduate student because they needed to learn this stuff and they didn't know it. And I did know it. So I was teaching them a lot of Python. I was teaching them a lot of not distributed computing, but a lot of high performance computing and stuff like that. Now, can you do both academics and work? That's a good question. There are several industrial positions that will allow you to do a lot of academic work, like biolabs, for example, wet labs. There's a lot of good industry wet labs out there that will help you do drug discovery and all that kind of stuff. And so you can definitely do that. With software, you can do it as well. But, the thing you have to keep in mind is academia's primary thing that they produce is academic paper. They produce research, right? Whereas companies produce items, they produce services, they produce things to be sold. And so because of that, you might find as an industrial person, you are not as motivated to publish, right? You have to do that all in your own time. Meanwhile, as an academic, sometimes, not all the times, but sometimes you find yourself, struggling for patent work and stuff like this because that's not a traditional publication and stuff. Now, obviously, the boundaries are very blurred here, and it's not really clear how one thing leads to another. But the question of can you do both? In principle, in computer science, yeah, the answer is generally yes. But in a lot of other areas like physics, it's kind of generally no, right? It just depends. Bukajar, thank you so much for following. Really appreciate it. Okay, so now I want to play all of these guys back to back. So Barnsley, Fern, TF star. Okay, we're going to watch all 4 of these animations. So the way the Barnsley Fern works is it's a composition of 4 different functions. One will bring your fern and turn it into a stem. Another will take your fern and turn it into the left leaf. Another will take your fern, turn it into the right leaf. And the last one will take your fern and make successively smaller ferns as you go higher and higher up to the right. So we're going to play these. The first one should create the stem, as it does. Perfect. Let's see, how many? We have a lot of extra frames here, so probably I should, in the final visualizations, clip the total number of frames. The next one brings you up. Perfect. The next one should create the left leaf. Yeah, I really do need to clip the number of frames. It's way too many frames. So this one should create the leaf over there. Perfect. And the last one should create the leaf on the left. Cool. Yeah, this is exactly what we needed. This is, in my opinion, the clearest representation of how the Barnsley Fern works that I think I've ever seen. It's clean. Okay, so how long does it take to do the visual? The visual stops 2 seconds. We have a lot of frames left over. So I'm going to go and, before committing this to GitHub, I'm going to modify some of these functions so we don't have as much time to wait at the end. So for example, I know this animation only lasts from 60 to 120, so I'm actually going to make it so the final frames here only go up to 200. And I'm going to do the same for the Barnsley Fern function in here. In fact, let me just see 600. All of these guys I think go to 600. So what is this guy? This guy is the quad transform. I'm going to leave that as it is because I think we're actually not even going to use that. The frame number is Barnsley Twiddle. What? Oh, Barnsley Twiddle is good. We want that to be 600. And what is this one? This one is just Barnsley. I think this one we also want to be... I think this one's fine. Yeah, I think this one's fine. Because I think it's just going to generate... Well, let's run it. Let's see what happens. Okay, so I'm going to run that function just to see how it goes. And while this running, we're going to make sure that all the other frames are good to go. So g++./Barnsley, and let's check a look at 600. Okay, so we have 600 here, but I think that's the one I wanted to keep because I think that's just Barnsley. Yep. This one is going to be for the quad transform. Keep that one. Barnsley Twiddle, keep that one. And this is just Barnsley. Perfect. Okay, so let's wait for this to run. Just make sure that 600 frames was actually good for that visualization. And then I think we're at a pretty good spot with all the visuals that we can start talking about the best way to describe the Barnsley Fern to people who maybe have never seen it before. And talking about how to extend iterated function systems from beyond the from beyond just Sierpinski's triangle, which is what we did in the original chapter. Ju, again, thank you so much for following. Really appreciate it. All right, let me get a little bit more water. It's going to take just a second to render. This is actually the longest of the functions. There's one other thing I wanted to do before committing this. Oh, yes. So after this, I'm actually going to check the Barnsley Fern transform again one more time, just to make sure it actually, we're not clipping any of the frames. And then I just have to run this overnight and get all the visuals that we need. So that's what I'll do. I'm going to have to create ones with a white background as well. So I want to check the Barnsley Fern transform for white background in just a second. So those are the last two things I need to do. So actually, let's just check them both at once. We're going to change the world color to white. Okay, so we're going to see what happens when this is shown. And yeah, that might actually be a good place to stop for today. It's 7 o'clock p.m. Well, when this is done, so maybe 20 minutes or so. So if you guys have somebody that you want to raid at the end of the stream, feel free to let me know. And we can see. So Freckled Scientist is online. Rocket Sage is online. Tim is online. Yeah, we can find someone to raid. Definitely. Definitely. So we're gonna let this run, and then we'll just take a look at the visual, and yeah, we're almost done. I'm super excited. Like I'm really excited for this. Wow. Can I finish a sentence? No, apparently not. I'm excited for this chapter. I was not excited. I wasn't super excited at the start of this week. In fact, I was thinking about just skipping over the Barnsley Fern because I was like, everyone already knows the Barnsley Fern. Everyone knows how it works, all this kind of stuff. But then I kind of realized I don't think people do. I pressed the wrong button. MPV, temp video.mp4. What's going on up here? What is that? Maybe because I started at a random point. Yeah, we're using too many frames. Yeah, definitely using too many frames. Avi Shadow, thank you so much for following. Really appreciate it. Okay, let me go up to the Barnsley function. I don't understand exactly what's happening there, but I think it's because maybe vector point, that's what's going on. So it should start at 0, 0, d. And I think actually we could have just done... We can count the number of frames here. So it goes from 60 to floor of I over bin size minus 20. Oh, it depends on the bin size. Yeah, it depends on how many points we're plotting at every step. Okay, that's fine. Okay, so we're going to run this one more time. g++./Barnsley, and this should be a white background version of one of the visualizations we just made. So I'm letting you guys know, if you need, it will be white background. Pull out your sunglasses now. Like I realize a lot of people are averse to, anything that's not dark mode. So this will not be dark mode for just a few seconds. We're going to have something on light mode on screen. So don't freak out. Let me get some water. It is taking longer than I thought it would, though. I thought I'd be done by now. Oh, I guess we are doing 10,000 points, so it might take a second. By the way, I hope you guys are all having a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And yeah, tomorrow should be a bit of a longer stream. I'm hoping to set all these visualizations off tonight. So like just while I'm sleeping, I'm hoping for them all to run. So we have them ready for tomorrow. Yeah, that's the plan. So we'll see how that goes. And so hopefully tomorrow we'll have all the visuals ready. And then we can just start writing the algorithm archive chapter and making the final set of visuals that we need making the final set of visuals that we need for our Barnsley chapter and also the Barnsley video. So the video, I want to use black background. The chapter, I want to use white background. And there's going to be some additional thing that I have to mess around with. Like, I'm going to have to do some light video editing. But I think it should still be okay. I think. We'll see. Yeah, okay, we might have some... Yeah, it might be a bit annoying, but we'll get there. It's taking a lot longer than I thought it would. Did I do something dumb? I did do something dumb. Crap. I left the old visual. So I was doing two visuals at once. Okay. That explains why it was taking so long. G++ /Barnsley. Alright, one more shot. This should take no time. Come on, please. I said it take... Like, don't embarrass me in front of the viewers. Like, I said it should take no time, and now it's taking like 10, 20 seconds. Okay, there we go. Okay, so, white background. Sunglasses on. There you go. Perfect. MPV. Oh, gosh, I can't type with sunglasses. Temp video.mp4. Ah, it looks kind of ugly, doesn't it? MPV. It's not so bad. Let me increase the number of points a bit. G++ /Barnsley. So the last one took, what, 30 seconds? So this one should take a bit longer. Arthur, I told you, sunglasses. You can put the sunglasses on. But I think you're right in saying that the red might be a bit too, like, it's too dark, I think, for that visual. But I think if we increase the number of points, it should look better. I'm a bit worried about the white visuals looking bad. So it's good that we're doing this. Oh, do we have enough memory? Yeah, we're fine. I'm always afraid we're running out of memory because I'm used to GPUs where you're like constantly running out of memory. But you very rarely run out of memory on CPU. Especially when I have 31 gigabytes of memory available. However, I can say that for some of my visuals back in the day when I was doing the Impossible Lenses video, oh man, I definitely ran out of space for that one. Like I was constantly like running out of my 32 gigabytes of memory. So basically, if you want poorly written code that uses all of your RAM, let me know. I'm your guy. So wait, the last one took 30 seconds. So this one should take 300 seconds, maybe, if the scaling is right. So we've got time. If you guys have any questions, comments, concerns, anything like that, feel free to let me know. I'm going to move over here really quick. Oh, I never even opened up Zernal today. It's been one of those days. Okay, go here. Let's just open up Zernal PP, and let's talk really quickly about how to explain this pedagogically. Okay, so the Barnsley Fern, okay, one second. Barnsley Fern. We need to talk about a bunch of different things. We already have chapters on affine transformations, on iterative function systems. So what we need to do is extend the iterative function, extend IFS to affine transforms. So I think that's going to be kind of the first step. Right. And I think that should be easy enough. I mean, it's not going to be too hard. One second. And then what else do we need to do? We need to introduce the functions, introduce transforms. And I think here we just need to show random points. Actually, I don't know the best way to do this. I need to think about that a bit. Let's play the video. MPV. Does that look better? Or is the red still too red? I don't know. I don't think that looks aesthetic at all. I think like that looks actually kind of, I think it looks kind of ugly, in my opinion. Okay, we're probably gonna have to mess with the colors a bit. Yeah, we're gonna have to mess with the colors a bit here. But this visual actually doesn't take too long, so we can play with the colors tomorrow if we want. I'm looking at my side screen as well, just to see what it looks like. But I think... I can't tell if it looks okay or not. Is the green too green? Oh, maybe my monitor has like a red shift to it. So maybe what we want to do is modify the colors so they're all just a little bit darker. Like if we make the green a bit darker, then yeah, if we make the green a little bit darker and the blue a little bit darker, then I think it all works a bit better. Let's play that transform again. There we have all the points. Move it down. I don't know. I mean, it's still there. Like, and the intro animation looks really cool. I'm a big fan of that intro animation. Okay. We'll worry about that in a bit. Okay, but I think this is a good place to stop for today. So let's see, who do we have to raid? We can do Skylius. Actually, we haven't done Skylius in a long time. How about we raid Skylius today? Yeah, let's do that. So that'll be it for today, guys. I'm going to go ahead and run the long animations in bulk this afternoon / tonight, so it's running overnight. Specifically, all these Barnsley twiddle functions and stuff, they take a while to run every iteration. So I'm going to get all those done, and then the rest of them I think we can do tomorrow on stream. I think. Yeah, I think we can. So we'll see how that goes. Anyway, that's it for now. So let's go start the raid on Skylius. She does a lot of space stuff. She's really cool. I think you'll like her. Skylius. Okay. So anyway, guys, thank you so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos. Actually, wait, one second. Is Skylius, did she just start? Or is she in the middle of streaming? One second. Give me a second before we start the raid. I want to make sure she's actually live and I'm not just putting you on like a welcome stream. It's still loading. Freaking ad. I have to wait for 30 seconds to see if she's if she's actually online or not. So I might just raid and see what happens. Okay, thanks guys so much for coming in, and I will see you guys next time. Bye guys.